Okay, so question 6, we have this system with a boom being supported as shown in the figure here. Okay, so now we want to find the tension T, this here, okay, in the rope which is supporting this boom. We want to find the tension in that direction, and also we want to find the forces exerted on the boom by the pin, the forces V and H. Okay, so now to find the tension, let us consider the second condition of equilibrium. Let us consider the vector sum of the torque about the point P, which is somewhere about the pivot here. Okay, so we are saying the sum of the torque must equal to 0. Okay, so the vertical component of this tension is going to give us T sine 50, and the perpendicular distance is going to be 3L over 4. Okay, and also the vertical component of the weight of this boom is going to be 400 sine 40, and it is at the center, which is L over 2. So we are going to have 3L over 4 multiplied by T sine theta minus L over 2 multiplied by 400 sine theta minus the weight at the top there, okay, which is 200, and it's situated at the far end of the boom, which is the distance L. So it will be 200 L sine 40 equals 0. Okay, so we have that 3 over 4 is giving us 0.57, therefore have 0.57 LT minus 128.86 L. If you work this out, you're going to have 128 minus that. Also the other one, you do the same, minus 1285.58 equals 0. Okay, therefore we take this to the other side, and therefore we're going to remain with 0.57 LT equals 1414.14 L, from which we can obtain T as 2480 newtons. Okay, so now that we have found T, our tension, we can now go ahead and find the forces H and V. So we have to note that the sum of the forces in the X must also be equal to 0, the first condition of equilibrium. So in the X here, we have the tension acting in the negative X-axis, and also H acting towards the positive X-axis. So we have the sum of the forces in the X, we have H minus T equals 0. This implies that H is equal to T, and our T is 2480 newtons. So we have found the value of H. Okay, so let's consider also the sum of the forces in the Y. We know that we have V acting upwards, the weight of the boom 400 newtons acting downwards, and also the weight 2000 newtons here acting downwards. So we're going to have V, the sum of the forces in the Y equals V minus 2000 minus 400 newtons equals 0, implying that V will give us 2400 newtons. Okay, therefore to find the magnitude of these forces, you know how to find the magnitude. We have square root of V squared plus H squared, substitute the values in there, and finally you get a magnitude of F as 3451 newtons. Okay, So you can go ahead and also find the angle theta with which this magnitude makes. Okay, so the direction of this force is theta equals tan inverse of v over h, v being our y component and h our x component, and the direction is 44 degrees. Okay,